third order differential equation, but this third order derivative is having single power here, no power. This is only one power. Degree is 1. Degree of this equation is equal to 1. Order 3. Order is 3 of this equation. Highest order terms, highest order derivative we find. So this is the highest order derivative of term, which is 3. So order is 3 undoubtedly. Now the power of that highest order term only we find out. What is the power of this? Only single. This is degree here 1. In this equation, this is also degree 1. Why? Because highest order derivative is second order derivative is this. This is first order derivative. Okay, its power is 2 undoubtedly, but we have not to consider this first order derivative. We consider this second order derivative here. This term is second order derivative. The power of this second order derivative is known as degree of that equation. Again, degree is 1. Degree of this equation is also 1. Well, power of this second order. So, and order is, let me write here, it is order 2. Order is 2 here because the highest order derivative is this. So order 2 power is 1. So degree is 1. The power of the highest order derivative is known as degree of that equation. So in this case, so this is second order derivative. So the second order derivative is having 3 power. This is 3 times multiplied. This derivative, second order derivative, which is the highest order derivative in this term. Order is 2, but degree is 3 in this case. Order equal to 2, degree equal to 3. 3. Why 3? Because the highest power, the power of the highest order derivative is 3 here. Is undoubtedly this is single order derivative, but we are not to go on power of this. This is 5 power, but this is single order, one order derivative, which is not the order of the differential equation. Order of the differential equation is 2. So this is the highest degree, highest order term. So highest order term is this second order term. This second order term is repeated how many times? Is having power. How many powers? So this is 3 powers. Is repeated 3 times. This 3 is known as degree of this equation. Simple. Okay, now in the last one, let me express the last one in a proper manner so that we can make it free from radical, free from fraction. Okay, so in this case, last instance I'm writing here, this is d square by dx square plus this is d by dx divided by d square by upon dx square. Okay, plus 5 by equal to 0. Now this is having a fraction, a radical, this upon this. First we have to free from this. We have to free this equation from this radical. What we take? We take LCM here. What is the LCM? D square by upon dx square is the LCM here. So this will be d square by dx square whole square now cross multiplied, plus this is nothing but d by dx. Okay, plus 5 by into this d square by dx square equal to 0 here. Okay, now again we can write it in a proper polynomial form. This cross multiply, this into 0 is 0. Finally, we obtain d square by dx square whole square. Try to understand. Plus d by dx plus 5 by into d square by upon dx square equal to 0. Now this is free from fraction or radical. This is a polynomial form of this differential equation. Differential coefficients are the term of this polynomial, undoubtedly. No simple x or y variables. Okay, but this polynomial in terms of derivatives, in terms of differential coefficients. This is a polynomial form. Polynomial form. A number of terms are here. Poly means many, and nominals means terms. Okay, so many term equation. This is three term equation. Okay, trinomial. So Now this is the polynomial form. Now we have to find out what is the degree of this equation. So first we have to search that what is the highest order of this derivative forming this differential equation. Highest order is 2. Highest order is 2 undoubtedly. So higher order of this equation is 2. There is no doubt about this. Degree is this. Power of this highest order derivative means this one. This is only single order. Single power here. Order is 2. This order is 2 here, d square by dx square, but power of this, it is repeated only one time. This is repeated 2 times. So degree is 2 here. So degree of this equation, simple, is equal to 2. Order is 2, degree is 2 of this equation. This is the proper polynomial form. First we have to convert that whole equation into proper polynomial form. Polynomial form, and polynomial means having the term, that polynomial is expressed in terms of derivative undoubtedly, because this is a differential equation. Then we find out what is degree and order. Degree is calculated after converting that into proper polynomial. Order is undoubtedly, order is 2 order. Even if we could express this in terms of polynomials, the order was 2 here. So in case of order, we may convert that into polynomial or may not convert, but order will remain same, but the order cannot be changed. Okay, so that highest order derivative is 2 here, order is 2. But in this case, there was power. If I just take that, what is degree of this highest order derivative? 1, here also 1. But we have to multiply them. We have to take LCM and then solve it. Proper form, polynomial form, we have to convert that. After that, we calculate degree. Degree is the highest power of the highest order derivative. Power of the highest order derivative is known as degree of that equation. This is the 2 order of second order derivative, which is the highest order of this differential equation, but this is repeated 2 times. What is repetition of that highest order term, highest order derivative, is known as degree of that equation. This is order degree 2. Okay. Now these are the 2 definitions of order and degree. Right? So order and degree are just expressed. It's very simple to find out. Now let me take these questions one by one. There are 25 questions I have taken, and they are very tricky sometimes, and some are very easy one. So in the first one, what is the order and degree? So let me write them, and I'll write here order and degree. Here it is order, I have to write here, and here it is degree of these equations. Okay, so what is the first point here? So first is d by dx plus y is equal to e raised power x. Now this is the differential equation, because this one derivative is found, one differential coefficient is found in this equation. So differential equation undoubtedly is a polynomial form. What is the order here? Order 1. Degree is also 1, because the highest power of this is repeated only one time. So degree is also 1. Whatever the repetition or power of that highest order derivative of that differential equation is known as degree. So degree is also 1, order is also 1. Simple. Second question, number 2. d by dx. Again, this is d by dx plus 5y equal to 0. Here order 1, degree 1. There is no doubt about this. Order is 1, degree is also 1. Why? Because we have to find the power of this derivative. The derivative is high, one order derivative, and their power. Now third, question number 3. Question number 3 is d square by dx square is equal to 1 plus y square. Again, this is a derivative. We can take these terms to this side undoubtedly, but this is second order derivative here. This is a polynomial form, there is no doubt about this. Or we could write it as d square by dx square minus y square minus y minus 1 equal to 0. This is derivative, differential equation. So it is also having the same thing. Order here, order is 2. This is highest order derivative to a second order. But degree is 1 here. So this is not repeated. Its power is only 1. Order and degree of this equation is, order is 2 and degree is 1. Simple. Let me take fourth. Question number 4 here is this. Let me first write it. This is dq by dx cube plus 5d square by dx square plus 3d by dx equal to 0. What is the order here? 3. Order is 3 here. This is order here, and power is or degree is 1 here, but power of this highest order term derivative is 1 only. It is not repeated 2 times, or is repeated only 1 time. Degree is 1. Okay, so the power of the highest order derivative is 1. So the degree is 1. Now fifth one. Question number 5th. Okay, this is d square by dx square plus d by dx whole square plus 3 by equal to 0. Okay, so here order is, because this is the second order derivative, this one, there is no repetition of this. D by dx is repeated undoubtedly, but this is single order. We are not going to think about this single order derivative or one order derivative. Talk about highest order derivative of this equation. Highest order derivative is this one. This is second order derivative, and power is 1 to degree is 1. Now sixth equation. Question number 6. Sixth equation is this one. Okay, sixth one is this d4y. This is d4y, fourth order derivative. This is dx4 plus 3y equal to 4 sine of x. So again, this is order 4, but fourth order derivative, but degree is 1 here. Now seventh. Question number 7. Okay, question number 7 here, or seventh question is d by dx whole cube plus 7y equal to twice 10x. Twice 10x here. But in this case, this is the single order derivative. Order is 1. Because this term d by dx is having power 3, there is no doubt. But it's only one order derivative. This is d by dx, one order derivative. Order is 1, degree is 3. Because this is repeated 3 times here. D by dx is having power 3. It is repeated 3 times. So degree is 3 here. Simple. Now 7th or 8th now. Question number 8. Okay, now question number 8 is this one. Okay, so this is d square by upon dx square plus 3 into d by dx whole cube plus 6 by equal to 0. Now in this equation, highest order derivative is this second order derivative. This is one time derivative. No, it's first order derivative. We are not to think about power of this. There is no doubt, as I have expressed already, we have to find out highest order derivative term. What is the highest order of this equation? The highest order derivative of term is d square by dx. This is second order derivative. So order is 2 and degree is 1. Not to think about d by dx whole cube. D by dx is one order derivative. Okay, we are not to think about this because power of this d by dx is 3. So order of degree of this equation is not 3 but 1 only. Why? Because we have to think about highest order derivative, highest order term. This is highest order derivative term here. This is d square by dx square. So order is 2. About this we have to think about. And this highest order derivative is having power what? What is the power of that term? This is only single power, is not repeated. If it is repeated 2 times, 3 times, 4 times, then we have to think about degree. So what is that? This is only one time, single time appearing. So appearance of the term, if this term is appearing one time, if it is repeated 2 times or 3 times or 4 times, that degree. is the repetition number, okay, of that highest order derivative. So eight questions we have taken. Now let me talk about 10 onwards. Now question number 9 onwards. 8 I have taken. Now 9 question onwards. Let me talk about. Now question number 9. Okay, so 9th question is, what the 9th question say? 9th is this one. D by dx. Okay. This is now 9th question. Question number 9 is d by dx plus 6y square plus y equal to 0. What is the order of this? Order 1, degree 1. Simple, think about this derivative. This is one order derivative. The power of this is known as degree. Now 10th, question number 10 is this. This is d by dx whole square plus y cube plus y per 0. So order is 1 but degree is 2. Because this is d by dx is repeated 2 times. This is 2 degree. Simple. 11th question 11. 11th question is d square by dx square, okay, plus 2 into d by dx plus sine y equal to 0. So the order 2, because this is second order term, second order derivative, d square by dx square, second order. Order is 2 and the degree is 1. Because this is not repeated, this is only coming one time. This is 1 degree. Now 12th, question number 12 here. Okay, 12th question is, okay, this is dq by ds cube whole square plus d square by dx square whole cube plus d by ds whole 4 plus by 5 equal to 0. Now in this case, try to understand. With the order here, the highest order derivative term is 3 times. This is third order derivative, dq by dx. This is d square. This is d by dx. Single order derivative. Second order derivative. This is third order derivative. The third order derivative is having only order is 3. Let me write here. Order 3 here. Order is 3 because this is dq by dx cube. Okay, so, and power of this dq by dx cube is 2. Degree is 2. So order 3, degree 2. We are not to talk about degree of this, power of this d square by upon dx cube, because this is the lower degree term, lower order term. This is the lowest. D by dx is one order derivative. This is second order derivative. This is third order derivative. Third order derivative only we have to think about. So highest order derivative is third order derivative. Degree of that is 2. Okay, now let me take 12th, 13th. Question number 13. 13th question is, this is very, very interesting. Y is equal to r into x plus under root a square r square plus b square. What is r here? Where r is equal to d by dx. Where r is equal to d by dx. This is smaller r. It's not r here. Y is equal to rs under root this. Now if I take rx here, this side, or this implies that y minus rs is equal to the square root of a square r square plus b square. Try to understand. Again we have to remove this radical sign. This must be free from radicals. Only then degree can be calculated. Okay, order can be calculated, yet it can be, okay, order can be calculated. Order is 1 only, because d by dx r is here. This is r square. Okay, this is d by dx whole square, because r is d by dx. This is d by dx whole square and output. Order is 1. What is degree? Let me First square this equation. It will be y minus rs whole square equal to a square r square plus b square. If I again open this, it will be y square plus r square x square minus twice x by into r is equal to a into r square plus b square. Now we have to substitute the value of r. Now let me express this here. Okay, let me rub all these. So this is the question number 13 we are talking about, so that it can be expressed easily. Now let me write what is r here. R is d by dx. R is equal to d by dx. So r, if I substitute this 13, question number 13, we are doing y square plus r square. R means d by dx. It is nothing but d by dx whole square into x square. X square that we write here. Y square plus x square into d by dx whole square minus twice x by into d by dx. Minus sign, if I take these two terms to this side, it will be minus a square into r square, that was d by dx whole square. It will be negative sign here. Minus b square equal to 0. Further we can write it down, simplify by, okay, taking common here, these two terms are common. What is this? This is x square minus a square into d by dx whole square. Try to understand this term, d by dx whole square, d by dx whole square, x square minus a square into d by dx whole square plus sign. This is y square minus twice x by, first we have write minus twice x by, we always write, this standard form. This is minus twice x by, sorry, minus twice x by into d by dx, this term, plus y square is y square minus b square now equal to 0. So this is the equation finally. Now this is the polynomial form, or we could write these two terms, but this one term is common here. Now highest order derivative, what is the degree of this order, and order of this equation, this whole equation is 1. This is d by dx, only one time derivative. This is first order derivative. The order of that derivative is 1. Degree is 2 here. Degree is 2 of this equation. Why? Because this d by dx is repeated twice. It is coming 2 times, repeated 2 times. D by dx into d by dx. Order is, so degree is 2. Order is 1 only. D by dx, and order is 1. As I just explained that r is equal to d by dx, so order is 1. But we have to remove those radicals. Radicals is square root. That square root is to be removed first. So after removing radicals, fractions, everything, then we think about what is degree. So that is the degree we express. Okay. This equation is now clear. Now let us talk about 40. Question number 14. Question number 14 is now. Let me talk about. This is question number 14 here. 14th question is this much. This is d square by dx square plus d by dx whole cube plus 3 by equal to 0. This is the equation, sorry, this one. Plus 3 by d square by dx square plus d by dx whole cube plus 3 by equal to 0. Now in this case, order and degree. So order, we have to think about this highest order derivative term. This is d square by dx square. This is d by dx whole cube, as I just explained. Order is 2, degree is 1. Only of this repetition we have to find out. Degree is 1 here. We have not to think about d by dx. whole cube. So dy dx is single order derivative. We have not to take power of this because this is one order derivative. Highest order derivative term we have to first select, and after that we find that what is the degree of that, what is the power of that, is it repeated, how many times it is repeated, 1 time, 2 times, 3 times, will it only coming one time, d square by ds square is coming only one time. If it is coming twice, that means whole square, d square by dx square whole square, whole cube, whole 4, that denotes the degree. Okay, so this is second order derivative, but degree is 1. Now 15th question. Question number 15 now. 14th is this. Yeah, and 15th is this one. This is dq. Let me write here dq by dx cube plus twice d square by dx square, okay, minus d by dx, simple, plus by 4 by raised power 4 equal to 0, simple. Now this is the highest order derivative or term which is having highest order. This highest order derivative is different coefficient is this. This is 3 order. Order is 3, degree is 1, simple. But we have to find out just power of this one. This is the 15th question number 15. Yeah, question number 15 is over, is fixed. Now let me take 16th, question number 16 here. Let me fix this also. Fixing this, solving this. 16th question is this. Here we have d square by dx square whole cube, yeah, plus cos of d by dx. Now here angle of this is cos of angle of cos is d by dx, undoubtedly derivative with the angle, but this is the highest order derivative. D square by order is 2, degree is 3. Why? Because this d square by dx square is repeated 3 times. Because its highest power is 3. They repeated 3 times. So 3 is the degree. Power of the highest order derivative, highest order differential coefficient is known as degree of that equation. That is the degree. Now let us talk about next question number now 17. Question number 17 is of what kind? Okay, so question number 17 is of what kind? Question number 17 is, okay, this is 16th. We're taking 17th is that one. Okay, 17th is, let me think, okay, see here. This is d by dx whole square minus sine square y equal to 0, minus sine square y equal to 0. Okay. In this case, what is order here? Order is 1, but this is d by dx only. 1 order derivative. This term is 1 order. This derivative is of 1 order, so order is 1, degree is 2, but this is repeated twice. It is repeated, I mean 2 times it is repeated. Now let me take 8th question. 18th question number 18th. Now this is 18th. Okay, this is dx. This is d by dx whole 4. Try to understand. D by dx whole 4 plus 3 by into d square by upon dx square equal to 0. Okay. Now the first, this term is having 1 order only. This is one order derivative, but this is second order derivative. Highest order term is this only. So this is order is 2, degree is 1. We have to take the power of this term, which is highest order term. Highest order term is d square by upon dx. So this is second order derivative. Second order derivative. So order is 2. Only the degree of that highest order term is to be thought about. Okay, so we have to just think about. We have to think about the highest order derivative. What is the power of that? Is it repeated? How many times it is repeated? That degree. Okay, so now 19th question number 19th. Question number 19 is of what kind? This is d5 by ds5, alright, plus y raised to power 6 equal to 0. Simple. Okay, no repetition of this. So order is 5 because this is d5 by ds5, fifth order derivative, but its power is 1 only, so degree is 1. Now let me take 20th, question number 20. Question number 20, what did you say this one? Okay, now let me end up there. Now question number 20, numbers, only now 5 questions are left. Let me now think about that. Question number 20. 20th question is this much. Under root radical. Under the radical it is d by dx. Square root of d by dx plus d by dx square root plus 2y equal to sin x. Okay, equal to sin x. Yeah. Now we have to remove this square root radical. Take this 2y to that side. It will be under root or under root d by dx is equal to sin x minus twice y. If I square both, squaring both sides or squaring both sides, we get it will be d by dx only is equal to sin x minus twice y whole square. Now if I open this, this is sin square x plus 4 is 4 y square minus 4 y into sin x minus 4 into y into sin x. This twice a into b minus twice a into b. This a square plus b square I have taken. This middle term must come in here. Sin square x minus 4y sin x plus 4y square, undoubtedly. This is the equation. So this is equal to d by dx here. This is the differential equation because this one term d by dx is there, is appearing. So this is the differential equation. Order either we can take this all these terms to this side, or if we write the standard form of this equation, d by dx minus sin square x minus 4y square plus 4y sin x equal to 0. Now this is the differential equation.